From agriculture to the electronics industry to thirsty children, clean water is constantly in demand. However, less than 1% of all water on Earth is accessible fresh water. For our global population to continue to develop and thrive, we need to turn the abundant ocean saltwater into fresh water, and we do this through desalination. Some common techniques include pushing salt water through a fine membrane that allows only pure water to pass, or heating up seawater until the pure water evaporates and is collected. But both of these technologies require lots of energy, which can be expensive and harmful to the environment. But what if you could get more clean water using the same amount of energy? Adsorption desalination is a new technology that can be coupled with existing desalination techniques to up to double the fresh water output. Let's start with the existing desalination method. Multi-effect distillation is an evaporation technique that is currently widely used to desalinate water. In this process, the seawater is sprayed over heated pipes, which evaporate only the clean water. This hot water vapor is then used to heat the next stage of the evaporation process, where the water then cools and condenses and is collected as pure fresh water. This is done several times at progressively cooler temperatures to generate more and more clean water. Unfortunately, the process is physically limited by the first and last temperatures in the sequence. The input temperature cannot be more than 70 degrees Celsius, or minerals in the seawater will cause scaling on the pipes. The output temperature has to be at least the ambient temperature so that the water will condense. This temperature can often exceed 40 degrees Celsius in arid places where desalination is the most needed. The good news is that adsorption desalination breaks the limit and allows the output temperature to be lowered to 7 degrees. This means that the process can include several more stages, or that each stage can operate at a much larger temperature difference. Both of these possibilities mean more clean water. The system is composed of a silica gel that easily adsorbs water vapor as cool as 7 degrees Celsius. But this gel has unique properties that allow it to be both hydrophilic and hydrophobic, depending on the temperature. At cool temperatures, the gel adsorbs the water, but when heated up, it releases the water again at temperatures above ambient temperatures so that it can condense in the final stage. The gel only needs to be heated to a temperature between 55 and 80 degrees Celsius. This heat is easily provided by renewable energy sources like the sun, or otherwise wasted heat sources like industrial exhaust. By adding adsorption desalination to existing systems, you can up to double the freshwater output without requiring any additional energy input.
Please subscribe to our channel and click the bell button so that you can be part of our notification squad.